What is a closure property? A closure property is a rule of binary operation that deals with whether a given set is closed or not. For any set to be closed, it has two conditions. The first two conditions is that the elements A and B that are combined by operation asterisk must be member of the given set. Suppose the given set is S. That means the elements of the two elements A and B that are combined by operation asterisk must be member or subset of set S. The second condition is that the result we are going to get from these two operations, the result we are going to get from the operation A asterisk B must also be member or subset of set S. The result we are going to get from operation A asterisk B must also be member of set S. Now, suppose we are given a set of an integers, a set that consists of an integers, and it is represented by S. The set is represented by S. So, and the set S consists of an integers. So, we are going to check whether this set S is closed under addition, subtraction, multiplication, and division. But before we move on, let's talk about integers. What is an integers? We have explained this in our previous videos. Kindly go and check it. Kindly go and check it in our previous videos. And the number system or types of numbers. So go and check it there. We have explained what an integer is there. But in summary, an integers is a number. Integers are numbers that are visible on number line. Integers are numbers that are visible on number line. They are the number that are on number line. -1, 0, +2, -50, -10, +40, +3, +5, etc. Any number that show on the number lines are what we call integers, like this: 0, +1, +2, +3, etc. -1, -2, and -3, etc. All those are what we call an integers. Now, what we are going to do is that we are going to choose any two integers randomly. Let's choose 2 and -3. These 2 and -3 are the ones that we are going to combine together in a certain operation. Now, let's test whether set S is closed under addition. So 2 plus -3. We want to check whether set S is closed under the operation 2 plus -3. So we are going to open this bracket. For us to open this bracket, we are going to multiply this plus and minus together. Now, plus multiplied by minus is minus, and 2 minus 3 is what? -1. Now, the two elements of these operations, operation 2 plus -3, that is 2 and -3, they are members of the set S, they are integers. That's the first condition. And the second condition is that the result we get from this operation is also an integer, is a member of set S. That means set S is closed under this operation 2 plus -3. It's closed on addition in this operation. It's closed under addition in this operation. Now let's test whether set S will be closed on subtraction, or will be closed under subtraction. 2 minus -3. So we are going to open this bracket. First, to open this bracket, we are going to multiply this minus and minus together. Minus multiplied by minus is plus. 2 plus 3 is 5. So therefore, this 5, which is the result of the operation 2 minus -3, is also the member of a set S because it's an integer. It's also a member of set S because it is an integer. That means set S is closed under the operation 2 minus -3. It's closed under subtraction there. Now, let's test whether operation S is going to close under subtraction. 2 times -3. So 2 times -3 is -6. And this -6 is also an integer. That is a member of set S. That means set S is closed under the operation 2 times -3. 2 multiplied by -3 is closed under multiplication here. Now, what about division? 2 divided by -3 will give us 2 over minus 2 over 3. Yes. And minus 2 over 3 is not an integer. That is, it's not a member of set S. That means set S is not closed under the operation 2 divided by minus 3. But it can close in another operation. Suppose we are given another number entirely, another number that are integers. For example, 4 and 2. And so now 4 divided by 2 is 2. And this 2 is an integer, it's a member of set S. So therefore, set S is closed under this operation. Set S is closed under operation 4 divided by 2 because the result given is also an integer. So set S is closed under division. It's closed here under the division. Now, suppose we are given a set of positive integers, which is represented by z plus. So this set plus consists of positive integers. Now let's test whether these positive integers is closed under division, subtraction, multiplication, and addition. We are going to choose any two positive number randomly. We are going to choose any two positive integers randomly. Let's choose plus 1 and plus 2. Okay, you can choose let's choose plus 4. Plus 4 and plus 2. 4 and 2. Plus 4 and plus 2. 4 and 2. Let's choose 4 and 2. Now, let's test whether this positive integer is closed under, this set z is closed under addition. 4 plus 2. And don't forget, this 4 is plus 4 and this 2 is plus 2. Okay, let's write it out. Plus 4 plus 2, it will give us plus 6. So, or we can neglect the plus 4 and plus 2. We can write it as simply as 4 plus 2, which is plus 6. This plus 6 is a positive integer. It's a member of set z plus. So therefore, set z is what? It is closed under the operation 4 plus 2. It is closed here because the result given here, which is plus 6, is what? Is a member of the positive integers. That means a member of the set z plus. What about subtraction? 4 minus 2 is plus 2. Yes, this plus 2 is also members of the positive. It is also a positive integers. That means it's a member of set z plus. So therefore, set z plus is what? It is closed under the operation 4 minus 2. It is closed under subtraction here. Likewise, it is closed under addition here. It is closed under subtraction here. Unless, for example, if we are given something, if the first letter in the subtraction, for example, we are given 2 minus 4 plus 2 and plus minus 4. Yes. Suppose we are given plus 2 and plus 2 and minus 4. Yes. Plus 2 minus plus 4. The answer will be 2. So for us to open this bracket, it will be what? Minus and plus is minus. 2 minus 4 is minus 2. And don't forget, these two elements in the operation 2 plus 2 minus plus 4, the two elements 2 and 4, they are integers. They are positive integers. Yes. But the result we get from the operation is a negative integers. It is not a member of z plus because it's not a positive integers. That means the set z plus is not closed under this operation 2 minus 4. It's not closed under subtraction in this operation. It is not closed under subtraction in this operation. What about multiplication? Let's test for multiplication. Let's test for whether it is closed under multiplication. Let's test whether it's going to whether 4 this z is going to be closed under multiplication. So 4 times 2, which is 8, plus 4 times plus 2 is 8. Now this 8 is also an integer. That means a member of set z, the result we get from the multiplication. So therefore set z plus is closed under this, or is closed under multiplication in the operation 4 multiplied by 2. What about division? 4 divided by 2 is the same thing as 2. Yes, set z is also closed here because the result that we get here, which is 2, is also a positive integer. So it's a member of set z plus. So therefore set z plus is closed under division in this operation 4 divided by 2. But if we are given something like, let's say 2 divided by 4. Yes, if we are given 2 divided by 4, let's check whether it is closed under positive integers. So the result we are going to get here is 1 over 2. And this 1 over 2 is not an integer. Not to mention positive integers, not even an integer. It's not an integer. Talk less of saying whether it is going to be positive or not, or negative integers. It's not an integer. So therefore, set z is not closed under the operation 2 divided by 4. So it's not closed in this operation. So but it is closed in the operation, the operation given here, that is operation 4 divided by 2. It is closed under division in this operation 4 divided by 2.